Myself, Pramod. I am studying in Electronics and Communication Engineering, 8th semester, East West College of Engineering. Today I am here to present my technical seminar topic on sensors on 3D digitization under the guidance of Professor Raghuveer CM, Assistant Professor, EC Department, East West College of Engineering. These are the contents. Machine vision involves the analysis of the properties of luminous flux reflected or radiated by the objects. So to recover the geometrical structure of these objects, either to recognize or to measure their dimension, two basic visions are there. One is passive vision and another one active vision. So sensors that capitalize on active vision can resolve 2D imaging systems. With the laser based approach, the 3D information becomes relatively insensitive to background illumination and surface structure. Digital 3D imaging can benefit from advances in VLSI technology in order to accelerate its deployment in many fields like visual communication and industrial automation. So the high resolution 3D images can be acquired using laser based vision systems. Complete images of visible surfaces that are rather featureless to the human eye or video camera can be generated. So color 3D imaging technology. Here three visions. One is machine vision, passive vision and active vision. So in the machine vision, it involves the analysis of the properties of the luminous flux reflected or radiated by the objects, and passive vision attempts to analyze the structure of the scene under normal light or ambient light. Stereoscopic vision is a passive optical technique. So the basic idea is two or more digital images are taken from the known locations. So active vision attempts to reduce the ambiguity of the scene analysis by structuring the way in the which images are formed. So auto synchronized scanner. So in this gives the auto synchronized scanner schematic representation. 3D surface map is captured by scanning a laser spot on a scene, collecting the reflected laser light and finally focusing the beam onto a laser spot sensor. So the geometric and photometric corrections of the raw data give two images in perfect registration with XYZ coordinates and with reflectance data. So sensors for 3D imaging. So this diagram shows the sensors synchronization circuit based upon the dual photocells. This induces stability and repeatability of range measurements in environment with varying temperature. A monolithic version of an improved circuit has been built to alleviate those problems. So laser spot position measurement sensors. High resolution 3D images can be acquired using laser based vision systems. With this approach, the 3D information becomes relatively insensitive to the background illumination and surface texture. So position sensitive detectors. This diagram shows the position sensitive detectors. So position sensitive detectors uses a video camera to capture and video and objects electronically. So images processing techniques also used to determine the locations of the object. So PSD offers the potential for better resolution at a low system cost. So this diagram shows the dual axis PSD. This PSD is a 5-terminal device bounded with the 4 collection surfaces. One terminal is connected to each collection surface and one provide a common return. Photocurrent is generated by light which falls on the active area of the PSD will be collected by those 4 electrodes. So the difference between up current and down current is proportional to the y-axis position of the light spot, and similarly the right current minus and left current gives the x-axis position. So laser sensors for 3D imaging. Here two types. One is CRPS3 and another one is DRPS3. So continuous response position sensitive detectors. So here the carriers are produced by light on the device which separated in the depletion region and distributed to the two sensing electrodes according to the Ohm's law. So the normalized position of the centroid when the light intensity fluctuates is given by P is equals to I2 minus I1 divided by I1 plus I2. So the actual position of the detector is found by multiplying P by D by 2. So D is the distance between two electrodes. So this is the schematic representation of CRPS3. So discrete response position sensitive detectors DRPSD. So DRPSD comprises the charge coupled devices and photodiodes equipped with the multiplexer for sequential reading, and CRPSD are very accurate because of the knowledge of the distribution, but working is slow. So for the measurement of light distribution, peak requires only small portion of the total array. So Partial light distribution is available. One can compute location of the desired peak very accurately. So here the first figure shows the monochrome system, and figure 2 shows the artistic view of the smart sensor with color capabilities. So next, proposed sensor color range. So it consists of specially distributed autonomous sensors to monitor physical or environmental. So this diagram shows the architecture view of a proposed sensor containing CRPSD and DRPSD. So here the explanation. So 3D surface map is captured by the scanning a laser spot onto collecting the reflected laser light from a different vantage point. And CRPSDs are used to find the centroid of the light distribution impinging on them, and to estimate the total light intensity. So the centroid is computed on chip with the well-known current ratio method, I2 minus I1 divided by I1 plus I2, where I1 and I2 are the currents generated by the type of sensors. So the subset is located around the estimate of the centroid supplied by the CRPSD. So these are the advantages. It reduces the size and cost, and better resolution at a lower system cost, high reliability that is required for the high accuracy 3D vision systems, and complete images of visible surfaces that are rather featureless to the human eye or video camera can be generated. So disadvantage is the elimination of all stray light is an optical system requires sophisticated techniques. So these are the applications. Intelligent digitizers will be capable of measuring accurately and simultaneously color and 3D for the development of handheld 3D cameras, and multi-resolution random access laser scanners for fast search and tracking on 3D features. So conclusion. From result we can see optical sensors have reached a high level of development and reliability which suits the high accuracy 3D vision systems. The availability of standard fabrication technologies shows about design techniques which allows the implementation of optic sensors that are applicable specific. The use of low cost CMOS technology leads to the competitive optical sensors. So future scope, anti-reflecting coating film deposition and RGB filter deposition can be used to enhance sensitivity and for color sensing. So these are the references. For any queries, my mail ID is pramodbalal123@gmail.com. Thank you.